Today we're going to be learning how to convert a number from base 10 to base 2. Now, the reason that this is important is because when working with computers, they actually use binary, which is in base 2. And binary is essentially compiled of using zeros and ones, whereas with our everyday language, we use 0 all the way up through 9, and that's how we formulate our numbers. So let's start looking at an example of a base 10 number. So for example, if we had, let's say, 149.625. So now the question would be, how could we essentially express this using our fully expanded base 10? And the way that we could do this is we could essentially go digit by digit. So we could start by 1, and now this is in the 100th place. So that would essentially be equivalent to 1 times 10 to the 2. And then we can look at this 4, which would then be in the tens place. So then we'll have 4 times 10 to the 1. And then you kind of see where the pattern's going, because then we'll go to the 9, which is in the ones place. So then we'll have plus 9 times 10 to the 0. And then we'll have this decimal point, so we'll skip over that and then go to our 6, where we'll have plus 6 times 10 to the negative 1, plus 2 times 10 to the negative 2, and then plus 5 times 10 to the negative 3. So that's actually how we express our base 10 numbers in their fully expanded form. Now, the question you may be asking is, now in base 2, like how would we actually go about that? Well, the method to do this is you essentially find first your largest 2 that you can essentially multiply up. So like, for example, 2 to the 1 would be 2, 2 to the 3, that would be 8, on and on and on. So the highest, I guess, factor or exponent of 2 that we can get up to without exceeding 149.625 would be 2 to the 7. And now this is equal to 128. So now the next step that we can actually do is we can subtract our 149.625 by our 128 to find what our remainder is. So we'll have 21.625. And then we basically repeat this process over and over again until we're left with 0. So now the next largest factor of 2 would be 2 to the 4, which is equal to 16. So by subtracting that, we would end up getting 5.625. And then, you guessed it, we're doing it again. So now we have 2 to the 2, which is going to be equal to 4, and then we'll essentially subtract that out. So then we'll have minus 4, so we'll have 1.625. Now notice the next interval of 2, or factor of 2, would be 2 to the 0, which is going to be equal to 1. So we'll subtract our 1, and then we'll be left with 0.625. So now we don't stop there, because we'll stop once we get to 0. So next what we can do is we can say 2 to the negative 1. That's going to be equal to 0.5. So now we're getting into our decimals. So then we can subtract 0.5, and then we'll be left with 0.125. And now we can finish this out with a 2 to the negative 3, which is equal to 0.125. So then we'll have 0.125 minus 0.125, and we did it. We got 0. So now, you might be asking, okay, that's great. Now what do we do? So let me tediously draw out 8 dashes here with a decimal point followed by 3 more dashes. So now essentially what we're doing is we're using all of these exponents that we have formulated up here above. So our 7, our 4, our 2, our 0, our 1, and our negative 3, our negative 1 and our negative 3. What we're doing with those is we're essentially placing a 1 in that corresponding spot to build out what our binary number will be. So for example, so we have our decimal place, and then directly to the left of it, we'll have 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and so on. And then off to the right side of our decimal, we'll have 2 to the negative 1, 2 to the negative 2, and 2 to the negative 3. So you can imagine for larger and larger base 10 numbers, we'll need more and more of these lines going across so that we can fully express what our binary digit will be. So now we can actually start filling in these blanks. So we actually had a 2 to the 7, so we'll place a 1 above our 2 to the 7. But notice we don't have any 2 to the 6 or 2 to the 5, so what we'll do is we'll place a 0 in these two spots. And then we have a 2 to the 4, so we'll place a 1 there, but we don't have a 2 to the 3, so we'll have a 0. But we do have a 2 to the 2 and a 2 to the 0, so we'll have 1s in both those spots. And then notice we have a 2 to the negative 1 and 2 to the negative 3, so we'll have 1s there, but we have no 2 to the negative 2. So what we can wrap this out by saying is 149.625 in our base 10. So this is how we denote base 10 by base 2. It's essentially just like a subscript of whatever base you're in. And that is equal to, hang in with me now, we have 100.101 in base 2. So now you know how to convert base 10 numbers into base 2.